Good day to you out here. I welcome you to my channel, Science Explained. Today, I want to treat some questions on logarithms, whereby laws of logarithms will be employed, and as well, laws of indices will play a major role. Logarithms and indices are interwoven. I will take my time to explain to the best of my knowledge for your proper understanding. Before I continue with the class, may I use the opportunity to say Happy Independence Day to my fellow Nigerians, because today is our country's Independence Day. We are celebrating 62 years today. And this is what I have to celebrate the Independence Day for my country, Nigeria. Happy viewing. Let me pause the video while you have a try at this question. Okay, let me call this one equation 1 and this one equation 2. I want to prove, show that means to prove. This is a quadratic expression equals to 72 raised to the power of y, which is an indices. Okay, how do I go about it? Since the result I want to get has nothing to do with logarithm, that means I should find a way to remove logarithm from equation 1 and 2 by employing one of the laws of logarithm. Log from equation 1 log x into minus 6 open into bracket to base of 3 equals to 2y. One of the laws of logarithm says that the base to the logarithm will carry this other side as a power and the logarithm will disappear. So that means I'm going to have x minus 6 equals 3 raised to the power of 2y. Let me call that one equation 1. Equation 3. From equation 2, I will do same thing. Equation 2 is log open bracket x minus 7 base 2 equals 3y. These 2 will carry this as a power. That means I'm going to have x minus 7 equals 2 raised to the power 3y. Let me call that one equation what? 4. Okay. Now, equation 3 and 4 do not have logarithm again, as you can see. So what do? I can multiply the 2 together to achieve this quadratic, because if I multiply x minus 6 and x minus 7 together, it will give me this quadratic expression. That means I will do x minus 6 open bracket x minus 7 bracket close equals 3 raised to the power 2y multiplied by 2 raised to the power 3y. Okay, when you open this bracket, you get x squared minus 13x plus 42. I've gotten this left side quadratic equals to 3 times 2 raised to power 2y times 2 raised to power 3y. Since the carriers are not the same and the powers are not the same, so definitely it means that I cannot apply law of indices. What do? I want to make the two powers to be the same. So I will only interpret 3 raised to power 2. 3 raised to power 2 will give me what? 9. Then power of y remains. Times 2 raised to power 3 will give me 8. And power of y what? Remains. So according to one of the laws of indices, when the carriers are not the same, but the powers are the same, you can multiply the carriers and pick one of the powers. So 9 times 8 is what? 72. Then you pick one of the powers, which is y. So that means this equals to this, which is this. x squared minus 13x plus 42 equals to 72 raised to power y. That's the end of that proof. Now, this is another question. You are given that log open bracket p plus 2 base 8 plus log q base 8 equals r minus 1 over 3. Let me call that one equation 1. And log into bracket p minus 2 bracket closed base to base 2 minus log of q to base 2 equals 2r plus 1. Let me call that one equation 2. We have to show that p squared is equal to 4 plus 32 raised to power what? R. How do we go about it? Again, what you are proving towards does not have any what? Any log. That means I will find a way of removing log. Logs from equation 1 and 2. From equation 1, since the bases are the same, base of 8, I'll pick one log and one base. Log to base 8, then p plus 2 in bracket. The addition between the logs here will become multiplication, then q equals r minus 1 over 3. Let me put this in bracket also. According to what the law I used in the first question, the base here can carry this as a power. That means I'm going to have q open bracket p plus 2 equals to 8 raised to power r minus 1 over 3. Let me do the same to equation 2. That means in equation 2 also, I will pick one log because they are the same base 2. I'll pick one log and a base of 2. Then the first number here is bracket p minus 2. This will change to division, and this is q equals to 2r plus 1. Let me put this in bracket also. Alright, so having done that, having done this base 2 will carry this one as a power. That means I'm going to have open bracket p minus 2 bracket close all over q because of this division equals to 2 raised to power 2r plus 1. Let me call this one equation 3 and this one equation what? 4. So let me multiply equation 3 and 4 together. So that means equation 3 times equation 4, that will be q into bracket p plus 2, q into bracket p plus 2, multiplied by p minus 2 over q, p minus 2 over q equals to 8 raised to power r minus 1 over 3 times 2 raised to power 2r plus 1. Okay. I think I need to extend this thing to this side. Multiplying equation 3 by equation 4, I'm going to have this times this, which is this times this, then this times this, which is this times this. Okay? Now, this q will cancel this q. What do I have left? Open bracket p plus q, p plus 2, open bracket p minus 2 equals, this will multiply this, but since this one is not in the power of base 2, so let me convert this to base of 2. That will be 2 raised to power 3, because 2 raised to power 3 means the same thing as 8, open bracket r minus 1 over 3, then times 2 raised to power 2r plus 1. Alright, when you open this bracket, you get p squared minus 4 equals to, since the bases are the same, I mean the carriers, you pick one, then 3 times r, that will be 3r, minus 3 times 1 over 3 will be 1. This times here we change to plus, then 2r plus 1. That's law of indices then. So p squared minus 4 equals to 2 raised to power 3r plus 2r, that will be 5r. Minus 1 plus 1 will cancel out. And 2 raised to power 5. This 2 raised to power 5 means 32, then raised to power what? R. So if I carry this minus 4 to this side, that means I'm going to have p squared equals to 4 plus 32 raised to power half, which is what we are asked to prove, isn't it? That was the end of the question. If you appreciate this video, please do not hesitate to subscribe to my YouTube channel for subsequent videos, and as well, like the button and share with others. Until we meet next time, bye for now. Once more, happy Independence Day to all Nigerians. Thank you.